One developer just built 88,000 lines of advanced malware in 6 days using AI, not a team, not months of development. One person with an AI coding assistant created a framework sophisticated enough to target AWS, Azure, Google Cloud, Alibaba, Tencent, Kubernetes pods, and Docker containers. I'm Sergio Popovici from Munich. And this is the story that changes everything we thought we knew about malware development. The discovery. On January 20th, 2026, Checkpoint Research revealed VoidLink, a Linux malware framework designed to compromise cloud infrastructure. According to the Register and Bleeping Computer, this wasn't just another piece of malware. The framework detects where it runs, adapts behavior based on environment, calculates risk scores, and adjusts evasion strategies in real time. But the malware itself isn't the story. How it was built is. The AI behind VoidLink. The developer used TRAE SOLO, an AI coding assistant made by ByteDance, the company behind TikTok. According to Checkpoint's detailed analysis, the AI generated a complete development plan spanning 30 weeks across 3 separate teams, sprint schedules, coding guidelines, feature breakdowns, testing criteria, a full enterprise software roadmap for building malware. One person followed that roadmap alone. The project started November 27, 2025. By December 4th, the framework had 88,000 lines of working code, a 30-week plan designed for 3 teams, executed by one developer in less than a week. Let that sink in. What should have taken a professional team months was accomplished by a single individual with AI assistance in 6 days. How researchers discovered the AI involvement. Checkpoint researchers only discovered the AI involvement because the developer made critical OPSEC failures, according to Bleeping Computer and Eli. Smaja, Checkpoint Research Group Manager, an open directory on the developer's server exposed everything: source code, documentation, sprint planning files, and crucially, the helper files that TRAE automatically generates. The developer copied those helper files to the server along with the source code. That single mistake exposed the entire AI-driven development process, providing researchers with unusually direct visibility into the project's earliest directives. And then there was Verostatal. On December 4th, a compiled version of the malware was uploaded to Verostatal, a service that shares samples with every security vendor in the world. Uploading your own malware to a global threat intelligence sharing platform? Not the smartest move, bypassing AI safety guardrails. The leaked documents reveal something fascinating. According to Checkpoint's analysis, the developer instructed the AI not to implement code or provide technical details about malware techniques. Researchers believe this was a deliberate attempt to bypass safety guardrails. The strategy: get the design and architecture first, then build it step by step using the blueprint. The developer used what researchers call spec-driven development, defining project goals and setting constraints, having the AI generate multi-team development plans covering architecture, sprints, and standards. The AI wasn't directly asked build me malware. It was asked to create documentation, structure, and guidance. The developer then used that AI-generated framework to build the actual malicious code, likely testing whether this indirect approach would slip past the AI's safety mechanisms. Why Zig? VoidLink is written in Zig, a relatively new programming language. According to Checkpoint's technical analysis, security tools aren't tuned for Zig patterns yet. Traditional detection methods that work for C, C++, or Go struggle with Zig binaries. This language choice was strategic, providing an immediate evasion advantage before a single line of malicious logic executes what VoidLink actually does. Once deployed, Checkpoint documents that VoidLink fingerprints the environment. It queries cloud provider metadata APIs to identify AWS, Google Cloud, Azure, Alibaba, or Tencent. It scans for installed security products by looking for specific process names and installation paths. Targeted security tools include CrowdStrike, Falcon Sensor, Sentinelone, Carbon Black, Falco, Wazoo, OSIC, Oscary, and Audit. When security tools are detected, the malware changes behavior. It slows down communication with command servers, reduces scanning activity, calculates environment risk scores, and adjusts operational tempo. Accordingly, in well-defended networks, it moves carefully. In unmonitored environments, it gets aggressive. This adaptive behavior makes VoidLink exceptionally difficult to detect through behavioral analysis alone. The plugin architecture. The framework includes 37 plugins according to Checkpoint's research, covering reconnaissance, credential harvesting, lateral movement, persistence, and anti-forensics. It steals keys, Git credentials, API tokens, and browser data. It wipes logs, cleans shell history, and overwrites deleted files with random data to prevent forensic recovery. If the malware detects tampering, it triggers self-destruct, taking all evidence with it. This isn't amateur hour, this is enterprise-grade operational security baked into AI-generated malware rootkit capabilities. VoidLink employs 3 different rootkit methods depending on kernel version, as documented by Checkpoint and the Hacker News. LD preload for older systems, loadable kernel modules for intermediate versions, and IBEP for modern kernels. The malware automatically selects whichever method works best for the target. The malware hides by pretending to be normal system processes with names like Worker, Migration, and Watchdog. According to researchers, any sysadmin glancing at a process list would scroll right past these, assuming they're standard kernel threads. Serverside rootkit compilation. A first, sysdig researchers discovered something never before documented in malware. The command server compiles kernel modules on demand for each target's specific kernel version. They call it serverside rootkit compilation. Previous malware either shipped multiple pre-compiled modules, bloating the implant, or required build tools on the target itself, increasing detection risk. VoidLink C2 server builds exactly what each target needs and delivers a custom rootkit. This solves the kernel portability problem elegantly without compromising stealth. Technical indicators for defenders. According to Checkpoint's published indicators, the C2 server operates at 8.149.128.10 on port 8080, hosted on Alibaba Cloud. The malware uses XOR obfuscation with KeyOXAA, an ICM covert channel with magic value OXOD, and self-destruct command OXFE. Attribution and intent. The code contains comments in Mandarin, real Mandarin according to Checkpoint, not Google Translate quality. Whoever wrote this understands kernel development. Researchers assess that a human was in charge, directing the AI, but AI generated most of the actual code. No victims have been found yet. Checkpoint believes the framework appears almost ready for deployment and may have been built to sell to other attackers rather than for direct use. The broader context. According to Group IB's report published January 20th, AI-related discussions on dark web forums increased 371% since 2019. Dark Elms, language models without safety restrictions, sell for $30. Deepfake tools cost $5. Tools that once required serious skill and months of development are now accessible to anyone willing to pay modest fees. VoidLink isn't theoretical. It exists, it works, and nobody has been caught. What this means for cybersecurity. Checkpoint's conclusion is stark. VoidLink demonstrates that the long-awaited era of sophisticated AI-generated malware has likely begun. This isn't low-quality script kiddie output or derivatives of existing open-source tools. This is enterprise-grade malware created by AI under human direction. One developer with strong technical knowledge achieved in 6 days what previously required professional teams working for months. The framework is advanced, modular, production-ready, and demonstrates capabilities matching state-sponsored threat groups. As Eli Smaja from Checkpoint told media, they only uncovered VoidLink's true development story because they had rare visibility into the developer's environment through the exposed directory. The unsettling question: how many other AI-generated malware frameworks exist that didn't make such obvious OPSEC mistakes? The defense challenge. Traditional security models assume malware development requires time, resources, and expertise. Defenders monitor threat actor groups, track their tools, and build detections based on observed patterns. But what happens when a single individual can generate sophisticated malware frameworks in days using AI? The development speed alone changes threat modeling. By the time security vendors analyze one sample and build detections, AI-assisted attackers could have generated dozens of variants with different evasion techniques, different languages, different architectures. VoidLink uses privilege escalation and persistence techniques that work on any Linux system. Understanding these methods is critical for defenders. Conclusion: VoidLink represents a watershed moment. We've crossed from AI might help attackers someday to AI is actively reshaping offensive capability development right now. The barrier to creating advanced malware just dropped dramatically. 1 person, 6 days, 88,000 lines of enterprise-grade malware. That's the new reality defenders must prepare for. The tools that used to require teams and months are now available to individuals with AI assistance and days. The era of AI-generated advanced malware isn't coming, it's here, and it's evolving faster than most security teams can adapt. Stay vigilant, stay informed, and remember, in this new landscape, the only constant is change.